electron domain. Okay. Formula, bonding electron plus lone pair. The bonding electron, I want to make it simpler for you. Sigma plus lone pair. Senang. Alright, we will look at the sigma. Tak payah fikir bonding electron apa benda semua tu. Apa bukan faham pun bonding electron tu apa. So nak senang, kita terus guna perkataan yang kamu senang nak faham lah. Sigma bond. If you remember, single bond is a sigma bond. Double bond is a sigma and pi. Triple bond is a sigma and 2 pi. Remember that? Okay. So we'll look at this formula. And $1 million sentence. All this, we only look for central atom. Your entire molecular geometry will based on one person, the central atom. Selain daripada central atom, orang lain kita tak payah tengok. Okay? Boleh? So, we will look at how do we identify the electron domain later on. And then the next thing, we have all the 5 geometry that you already have. Ada atas nota, so I don't want to go through it one by one sebab saya akan buat soalan terus dan saya akan ajar untuk lukis terus. Okay? Alright? And for all the question that I have given to you, saya tak akan bincang dah Lewis structure dia macam mana. Just let me know if my structure is different from yours ataupun yang saya lukis adalah salah. Okay? Then let me know. So we won't talk about how do we get the Lewis structure. Just I want you to check the total valence electron. Make sure the total valence electron is correct with yours. Make sure cara saya tolak adalah sama dengan kamu. Then your flow of answering should be the same. And then moving to the first step, like I say, we are going to look for something called electron domain. Okay, before to get the step, you have your Lewis structure. We need to find electron domain. Formula yang saya guna, lone pair, sigma plus bonding pair, lone pair. Sama je kalau bonding pair plus lone pair tu. Sama je. Okay. And then over here, your sigma is 1, 2. And like I said, we only focus on one guy. We only focus on your central atom. Central atom tak ada lone pair. Therefore, the electron domain that I have over here is 2 plus 0. Jangan congak terus. Sebab kita akan guna benda ni. So, tulis 2 tambah berapa, 1 tambah berapa, or so on. Sebab kita akan guna benda tu nanti. Equals to 2. Alright, tak payah tekan calculator pun. Then, when it's equals to 2, we look at your basic geometry. Your linear, your electron.
Miss keluar.
Guys, just please come back to college. So that nothing can stop us, you know. Suren, can see the screen already? Yeah, nampak dah ke?
Nampak.
Okay, Suren, can you see the screen? And am I still in the tool? Oh dear, just take turn. Satu crash and then yang tu okay, and then you just crash again. Oh dear. Finger crossed, nothing will happen again. Suren, is the screen visible?
Yes.
Dah nampak? Good, perfect. Okay, kita sambung sikit. Alright, so your electron domain that we have just calculated will actually be the one that determine your basic shape. Okay, this guy is the one that will determine your basic shape. Bila kita dah tahu electron domain 2, straight away kita boleh tulis dah, dia adalah linear. Alright, that is the basic shape. Dan bila kita dah tahu dia adalah linear as a basic shape, nak tahu molecular geometry. Next thing yang kita nak adalah molecular geometry. Molecular geometry ataupun molecular shape sama. Okay, molecular geometry atau molecular shape sama. So molecular geometry or molecular shape will depends on this thing that you calculate just now. Kalau dia tak ada lone pair, ladies and gentlemen, kalau dia tak ada lone pair, molecular geometry akan sama dengan basic shape. Linear. Okay, kalau dia tak ada lone pair, 2 tambah 0, lone pair tak ada, so molecular geometry akan sama dengan basic shape linear. That is the reason why saya kata jangan congak. Nampak? Okay. So, when you get the molecular geometry, and that is how your linear should look like. You have your centratum, you have a straight line. No matter how you pusing pun, dia tetap akan jadi linear. Afif, what do you think the bond angle will be?
Yes, me.
What do you think the bond angle will be?
Bond angle 180.
180. Afif, you are landing very, very comfortable. You know what? Right after this lecture, I want every structure with the geometry, with the basic shape, with the bond angle submitted. Memandangkan kamu tak nak hantar kerja kepada Puan Zalila, so hantar kerja kat saya. Kawan kamu duduk macam ni weh. Dengar kuliah. Who do you think you are? That smart? Next. When you are done with all this, when you're done with the electron domain, you're done with the electron domain calculation, getting the basic shape, molecular geometry, and bond angle. Starting from today's lecture and starting from this second, guys, you need to do one thing. Semua Lewis structure kena dalam bentuk yang betul. Okay? Dan tak payah padam yang ni tak payah potong, tak payah padam, tak payah liquid, tinggalkan dia. But redraw. You need to redraw your beryllium fluoride in the correct geometry. Linear saya tak payah ajar sangat. Linear, it should look something like this. So, kamu kena lukis balik your Lewis structure in the correct molecular geometry that you determine. That is how you answer. Okay, sebab akan dapat markah. Obviously, bila saya suruh lukis balik tu sebab nak dapat markah lah. Okay, question so far? Yes?
Must we label the angle on the Lewis structure?
Okay, do we still need to label the lone pair on the Lewis structure? I would say yes. Okay. Alright. Lagi. Okay, simple. So, benda baru kita hari ini sebenarnya adalah electron domain, but it's actually 100% depends on your Lewis structure. Okay, so make sure your Lewis structure is correct. Next thing that we will be going through is your Trigonal Planar. Just a kind reminder, Trigonal Planar over here means your electron domain adalah sama dengan 3. Look at it. Dua-dua ni basic geometry untuk your Trigonal Planar and basic geometry untuk your V-shape adalah Trigonal Planar. Tapi yang saya nak ajar, macam mana Trigonal Planar boleh jadi V-shape nanti. Okay? So this is the basic geometry. So going one by one. The second Lewis structure that we have, BH3. Betul? Lukisan saya? Okay. Moving up to your electron domain. So moving to your electron domain over here. Fazana Hasman. Electron domain berapa tambah berapa? 3 plus 0, which is 3. Because we will only again focus on the centratom boron, looking at your boron, knowing that your boron only having sigma bond. So 3 plus 0, do not jump it. Jangan work it out terus electron domain sama dengan berapa. Okay? Same thing, I will normally write the basic shape terus kat bawah dia. Bila 3, saya akan tahu basic shape saya trigonal planar. Okay? Dan kalau masa saya jadi student, saya tak suka hafal. Sebab saya jenis study last minute. Sayang, saya study last minute dapat 4 flat. Hang kalau study last minute tak dapat 4 flat, hang tak payah study last minute. Okay? That is the stupidest thing ever. So, what do I do when I was a student? Due to the not enough sleep, I won't imagine. I will draw straight away. Okay? I will remind myself, conting je kat tepi tu, exactly like what I conting. Conting je, oh, how should my trigonal planar look like? Something like this. In a 2D. Your trigonal planar, kenapa nama dia trigonal? Is a triangle. Okay, can you see the triangle? It's a triangle. And why the name is a planar? Because when this triangle located on a plane, duduk atas satah, dia akan jadi flat atas satah tersebut. Alright, dia adalah flat atas satah tersebut. Nampak? So, bila dia flat atas satah tersebut, that's why we call it as a trigonal planar. And bila dia adalah trigonal planar, boleh duduk atas satah nicely like that. Sayang, dia adalah segitiga sama. Betul? Alright? Dia adalah segitiga sama. See that? And straight away to the bond angle. Kalau dia adalah segitiga sama, 360 divided by 3. What would be the bond angle? Aina? Aina Izzati? The bond angle of this, alright, the bond angle of trigonal planar is 120. Segitiga sama, betul? Dan sama macam tadi. The best thing adalah bila lone pair sama dengan kosong. Bila lone pair sama dengan kosong, your molecular geometry will be the same as your basic. Itu cara paling senang. Tengok lone pair. Lone pair tak ada. So, molecular geometry, trigonal planar. Balik. Betul? Dan since dia adalah trigonal planar yang sama, dan bond angle pun takkan ubah. Bond angle akan jadi 120. Nampak? Okay, setuju? Alright? Done. Like I said, anything happen is, my drawing, saya memang saja lukis drawing saya bukan dalam bentuk yang betul. Okay? So, normally kamu awal lukis tu, kenapa saya suruh lukis balik? Sebab dari awal saya tak nak kamu fikir complicated sangat. At the first beginning, benda yang paling penting still adalah total valence electron kena betul, Lewis structure kena betul. So, dari awal tak payah fikir apa? Tak payah fikir shape. Get the electron domain, then we talk about the shape. So, trigonal planar, nak lukis 2D. Macam mana? Boron. Satu atas, segitiga. Tak payah guna projector untuk measure 120. Tapi mata kasar saya kena nampak dia adalah 120. Mata kasar saya kena nampak segitiga. Of course, other than a triangle like this, guys, this is also a triangle. Betul? This is also a triangle. Means, my triangle, my trigonal planar, can also look something like this. Agree? Nampak? Boleh pusing sikit dah otak tu? Okay, it will be exactly the same kalau Miss Wong draw like this. Dan dia masih adalah trigonal planar. Agree? Bijak sikit? Okay? So, saya bukan takut apa. Saya takut objektif keluar. Hampa kan nak sangat online exam kan. Saya takut objektif keluar ataupun saya takut soalan exam keluar. Dia bagi drawing. Dan dia tak bagi drawing yang kamu biasa lukis. Sayang, sama je. Janji bentuk tu ada. Betul? Okay. Happy with that so far? Senang. First thing, we are going into the first structure that having lone pair. So, looking at your central atom, sulfur. Same story sayang, kita akan ulang benda yang sama sebab saya bagi 12 ke 13 structure. We are going to repeat the same flow for 12 or 13 times. And at the end of the day, kalau kamu tak boleh kira lagi electron domain, it's not because you are not smart. It is because you don't bother. Okay? Zulaika? How many plus how many?
2 plus 1.
2 plus 1. Thank you. That will give rise to a 3. Kenapa 2 plus 1? I have a sigma over here. A sigma over here that is my pi. And I have a lone pair. So 2 sigma plus 1 lone pair. 3. I don't have any easier way. I think this is already the easiest. Okay. Bila dapat 3, sama macam tadi sayang. 3 bermakna trigonal planar. So 3 basic shape, bracket terus, trigonal planar. Okay. Betul? Kalau siapa yang tak faham kenapa trigonal planar, that is my basic shape. Basic shape, basic geometry sama. Okay. And macam saya cakap, trigonal planar, contenglah. That is how my trigonal planar should look like. Betul? Yang di mana bond angle dia, kalau basic 120. Setuju? Tapi masalah dunia wujud, bila trigonal planar, is because I have 3 bonding. Alright? Dia jadi sebab saya ada 3 ikatan. Tapi masalahnya, look at my drawing guys. Look at your drawing. Your drawing right now don't have 3 bond. I only have bond. Alright? And a lone pair. So in the other words, salah satu bonding kena ganti dengan lone pair. Mana satu nak ganti dengan lone pair? Anyone. Kenapa anyone? Because the bond angle is the same. Bila bond angle semua adalah sama 120, okay, kamu pusing mana pun, sayang, oh dia dah jatuh dah. Dia memang tahu saya nak buang dia. So dia dah jatuh. Salah satu kena ganti dengan lone pair. Betul? So let's say I dah berlubang dah polystyrene saya. My lone pair, nampak? I think you can see the lone pair better. Okay, so this is our cute little lone pair over there. I don't have anything to replace that. It's just a piece of paper. Okay, so that is your lone pair. And looking at your shape right now, do you still have the trigonal planar? Ada lagi segitiga? Tak ada dah. Segitiga dah hilang. Dan obviously, apa yang kamu dapat sekarang is what we call two name. Your molecular geometry is what we call, anybody? What is the name?
V-shape.
V-shape.
V-shape. Any other name other than V-shape?
Band.
Band. Okay, to show you the V-shape by the way. Belajar ABC ke? Belajar sampai V ke? Mana tahu pergi tadika belajar ABC je, betul Afif? Alright? Sebab pangai teruk punya pasal kan? So, that is your V-shape. Okay? So, your molecular geometry right now is a V-shape. Your V-shape is coming from the trigonal planar. Dalam exam, model tak ada. Miss Wong tak pegang model depan kamu. So, dalam exam nak buat macam mana? You know what I usually do? I will do this. I will draw the trigonal planar. Like what we are drawing just now. Okay, dan saya tahu saya ada satu lone pair. So, I will just simply cut the bond, replace with lone pair. Nampak? Yang tu boleh buat dalam exam. Because you won't have this. Alright, dan saya tak nak kamu imagine. Your imagination sucks. So, stop doing that. Okay? And do this. Lukis je 2D tu, potong satu ikatan, ganti dengan lone pair. Sebab kamu ada satu. Dan kamu akan nampak the molecular geometry yang tinggal. You can see the V-shape right now. Okay? And what do you think the bond angle will be? What would the bond angle be kalau original saya adalah 120? Remember the repulsion we talked about just now? Lone pair, electron, ikatan penuh dengan elektron 2. So what will happen is the lone pair akan tolak ikatan tu jadi kecil. Saya tak boleh nak tolak sangat sayang. Okay, because I still want to use it. Kalau tak dia pecah. So dia akan tolak daripada luas, dia akan tolak jadi kecil. Dan kecil sampai mana? Tak payah tahu. Kamu hanya perlu tulis less than 120. Okay, less than 120 degree of course. Okay. Reason why less than 120 degree? Because we have a lone pair. The lone pair repulsion is stronger than the bonding pair repulsion. Kamu akan tanya, teacher, ikatan dengan ikatan akan tolak juga kan? Ya, ikatan dengan ikatan antara ni dia akan tolak. Tapi saya ada lone pair. Lone pair tolak lagi kuat sayang. Ingat. Okay. So lone pair will repel stronger. That's why you have your V shape and then the bond angle 120. Do not stop that. You takkan dapat markah sebab cakap V shape. You kena lukis V shape tu. So your sulfur dioxide shall look something like this. Double bond pun double bond lah. Tak kisah. Okay. And then the lone pair semua tak berubah. Tadi ada orang tanya dah, lone pair kena lukis balik tak? Kalau tanya saya kata yes. Okay. And this is the lone pair. And I want you to learn how to draw the trigonal planar. How to draw the V shape kalau bentuk saya berubah. Kalau Miss Wong lukis my, what do we call that? V shape looks something like this. Kenapa saya ajar 2-3 jenis? Bukan sebab apa. Saya nak kamu nampak kedudukan lone pair tu. Alright? Kalau bentuk V shape dia adalah like this. I hope you can see where is your lone pair. Betul? Lone pair kena duduk atas. Lone pair tak boleh letak suka hati. Kehadiran lone pair yang akan menyebabkan bentuk dia berubah. So, kedudukan lone pair adalah benda yang paling penting. Is that clear? I can finally see Afif is working. Alright, you are a boy that are pretty horrible because if you are nobody forcing you, you don't bother your life. Pathetic. Question so far? Alright, class H8P2, Zavanis and the gang, Hizam and the gang, Human and the gang, Saigi tutorial. 1 hour after this. 1 hour after this, you cannot answer any question that I give to you. You are done. Okay? So pay close attention. Next, our basic shape that we want to look at is tetrahedral. Okay? Tak payah lukis sampai 3D macam ni dalam exam. Okay? Basic shape of tetrahedral, 2D, as simple as that. Okay? Budak selalu bukan tak faham. Kadang-kadang budak struggle nak lukis. Padahal kamu kena lukis. Right? And over here, you can see from your tetrahedral basic shape, this is your tetrahedral, we can change into 2 more. Trigonal pyramidal, V shape. Satu je sebab dia. Kehadiran lone pair. Betul? Dan yang paling penting sayang, macam mana kita nak tahu basic shape dia adalah tetrahedral? Look at the electron domain. The electron domain semua hasil tambah adalah 4. Dan saya tak tahu kamu perasan ke tak. Bila hasil tambah dia 4, nampak tak terminal dia ada berapa? Tetrahedral. Nampak? Tak payah hafal pun. Alright? When it's a tetrahedral, bermakna dia ada 4 ikatan. 1, 2, 3, 4. Tetrahedral. Electron domain 4, tetrahedral. It's not really benda yang kamu kena hafal pun. Okay? Alright? Easy. Next. Alright, saya dah malas tulis. So, saya dah tulis siap-siap semalam. Next, that is your Lewis structure CH4. Dalam tetrahedral yang saya pilih adalah CH4, ammonia and water. Soalan 3 structure ni pernah keluar dalam final as 1 question. Hanya 3 molekul. 3 molekul soalan tu 20 markah. Okay? So, pay close attention. Learn that. So you have your CH4. I think your CH4 looks something like this. A very simple Lewis structure. One of the simplest. Electron domain. Afif?
4 plus 0.
4 plus 0 due to the presence of 4 sigma bond over here and your carbon having no lone pair. Easy. And disebabkan dia 4 kat sini, therefore your basic shape, if you want to write, okay, your basic shape will be tetrahedral. And like I say, lukis tetrahedral tu, conteng je. My tetrahedral shall look something like this. And tetrahedral is this. Dia besar sebab biasa saya guna dalam kuliah face to face. Your kuliah, siapa yang pernah masuk dalam kuliah tu, dia tahulah dalam kuliah tu besar kan. So dia jadi besar, tapi bila duduk depan kamera ni, dia jadi macam better with the light or better without the light? No difference. Oh, fine. Leave it there. Okay, that is your tetrahedral. Okay, 3 kaki kat bawah adalah seperti kaki ayam. Kenapa saya kata kaki ayam? Because when I put it on the plane, SATA, remember my plane? And when I put it on the plane, dia takkan duduk atas SATA tu. Dia akan naik sikit. Nampak tak? Alright? Dia adalah exactly macam kaki ayam. Okay, dia adalah exactly macam kaki ayam. And then, next, tahu ke kaki ayam ada kaki? And kaki ayam bukan peha tau. Do you know, bawah peha tu that is actually claws? For God's sake, mana tahu orang kata what? City boy, city girl, you know. Yeah, that is how your kaki ayam should look like. Dan tengok cara Miss Wong lukis. Betul tak kalau Miss Wong lukis tetrahedral like this? Boleh tak lukis macam ni? Atas ni, alright. Bawah dia ada apa-apa tak? Bawah dia ada apa-apa tak? Tak ada weh. So dia tak duduk bawah dia. Nampak? Dia tak duduk bawah dia. Yang ni yang saya paling pantang. Sebab budak akan selalu lukis tetrahedral like this. Yang selalu kita jumpa budak lukis tetrahedral like this. No. This is not the correct drawing of tetrahedral. Your tetrahedral shall be like this. Sengit. Alright? Yang kedua tu sengit. Tak kisah sengit ke kiri atau sengit ke kanan. Tak suka kiri, you love right. Always go right. I'm happy. Tapi yang pasti dia tak boleh duduk bawah, and I'm showing you kenapa dia tak boleh duduk bawah, guys. Bawah tu tak ada apa. Nampak? Alright, bawah tu tak ada apa. It's a kaki ayam. Alright? And the bond angle, Naili, what is the bond angle of your tetrahedral?
Bond angle is 109.5.
109.5 is a 109.5 degree. And how do we prove every single angle is a 109.5? Simple. Bila Miss Wong pusing benda ni, alright, bila Miss Wong pusing benda ni, they are still having the same shape. Nampak? Bila Miss Wong pusing macam mana pun, they are still the same shape. Betul? Alright? Which means the angle is exactly identical. Alright? The angle is exactly identical sebab bila saya pusing macam mana, bentuk dia tetap sama dan tak lari. Make sense? So every bond angle over here will be 109.5. Make sense? Okay? And the same story, the same thing. Cara yang paling senang saya ajar, kita tengok yang ni. Selain daripada tengok final, kita tengok lone pair. So bila lone pair tak ada, bermakna your basic shape akan sama dengan molecular geometry tetrahedral. And the bond angle, like we agree, 109.5. Setuju? Okay. Lukis balik, your Lewis structure is not in the correct shape. So, carbon tengah, hydrogen duduk atas, lukis dulu ikatan. Saya biasa buat, saya akan lukis ikatan dulu kalau kamu perasan. Sebab saya nak nampak dulu shape tu. Baru saya masukkan terminal atom saya. Alright? That is the normal way that I will do. Supaya kita nampak shape tu betul. Can you see that? Saya biasa lukis ke kiri. Kamu nak lukis ke kanan, silakan. Alright? Okay, saya biasa saya je. It's nothing wrong. Okay? And of course, we always have more option on how you draw. Sebab kita boleh pusing-pusing benda tu. And that's why, guys, it is still a tetrahedral if I have your drawing like this. Betul? Is that still your tetrahedral? Can you see saya tidurkan dia? Alright? Saya basically tidurkan dia. It's still your tetrahedral. Of course, kalau kita lukis terbalik like this, tak ada masalah. Dia masih adalah tetrahedral kamu. Lukislah macam mana pun. Make sense? Okay? Patricia, okay? Alright, Patricia, okay. So next, Patricia. Patricia Sabadin. How many plus how many? 3 plus 1, sigma, 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 lone pair. That's why giving up to the 4, where your basic shape over there is your tetrahedral. with the bond angle original is 109.5. But right now, we have a lone pair. The problem arises is kita ada lone pair. Okay? So that is my tetrahedral. Then since we agree that the bond angle O is the same. Sama cerita macam Trigonal Planar tadi. Saya nak ganti dengan lone pair. Betul? Saya nak ganti dengan lone pair. Sebab saya ada satu lone pair kat sini. So, cara yang sama Miss Wong akan buat dalam exam is, I will remove any of the bond and I replace with lone pair. And why I say any of the bond? Because it's a tetrahedral with the same bond angle. Bila ikatan dia sama luas, hang buang mana pun sama je. Atas drawing tadi, saya buang yang atas. So, kat sini saya tak nak buang yang atas, saya buang yang kiri kanan. Okay? And why I say the bond is the same? Nampak? Nampak sama balik? Betul? Alright, dia akan jadi sama balik. Okay, dia akan jadi sama balik. See that? And of course, my lone pair, kedudukan lone pair tak boleh salah. Lone pair saya duduk atas ni. So that is where my lone pair located. Okay, and first question, is that trigonal planar? Suran, is that trigonal planar?
No.
No. Kita tengok sikit ya. Sayang, dia tak duduk flat atas SATA. Saya tak boleh nak sentuh my polystyrene ball. My polystyrene ball tak boleh sentuh SATA tu. Okay? Kaki saya dah sentuh dah. Alright, kaki saya dah sentuh. Tapi polystyrene ball saya tak sentuh. Because it's not a flat. Remember kaki ayam kamu? That is your kaki ayam. Okay? Therefore, the name of this thing is what we call Trigonal Pyramidal. Okay? Kenapa nama dia Trigonal Pyramidal? Sayang, I hope you can still see the segitiga. Betul? Can you see the segitiga? Alright? Segitiga ni sekarang, dia tak duduk atas SATA, dia tak duduk plane, dia tak duduk flat. Betul? Dan kalau Miss Wong tutup permukaan-permukaan ni, saya harap kamu nampak satu piramid. Okay? Kalau kita tutup permukaan ni, kita tutup permukaan ni, dia akan jadi satu piramid. Betul? Piramid berkaki tiga. Trigonal Pyramidal. See that? Okay? And position of my lone pair. Look at the position of my lone pair. So if I want to redraw the Trigonal Pyramidal, your N, and then the kaki ayam, and then the lone pair kena duduk sini. Sebab kalau kaki ayam saya ke bawah, lone pair saya duduk atas. Betul? Apa jadi kalau lone pair saya duduk kiri? Kalau lone pair Miss Wong duduk kiri, kaki ayam kamu akan bertentangan arah. Can you see bertentangan arah katanya? Alright, it will be over here. Nampak? Okay, so open up your mind on the drawing a bit. Okay, open up your mind on the drawing. And most important thing that I want to show you over here is the position of lone pair is extremely crucial when you have the lone pair. Kamu tak boleh letak lone pair suka hati sekarang. Sebelum ni lone pair nak letak mana, tak kisah letak je lah. Suka saya lah, saya nak letak mana. Betul? Tapi sekarang lone pair tak boleh letak suka hati. Okay? And the bond angle is less than 109.5 degree. Same story. Kenapa less than 109.5? Lone pair ada repulsion stronger. So, ikatan akan ditolak dan jadi kecil. Okay? Ikatan akan ditolak dan jadi kecil. So, dia akan jadi less than 109.5. Yang tu tak ada apalah. Senang. Okay? Question so far? Easy? No. Safi, electron domain?
2 plus 2.
2 plus 2. So your sigma kat sini adalah 2, lone pair kamu adalah 2. So if it's a 2 plus 2 equals to 4, what is your basic shape, Shafi?
Tetrahedral.
Tetrahedral. The original bond angle of tetrahedral, Shafi?
Wait. Saya tak faham dia.
Bond angle of the tetrahedral before anything.
Less than 107. Less than 107.
I say the bond angle of the tetrahedral. Original without anything. Even?
Tak faham ni dia.
Even bond angle?
109.5.
Original is 109.5. Class, setuju? Over here. Back to your tetrahedral tadi. Alright, back to your tetrahedral. Tapi masalah kat tetrahedral sekarang, alright, masalah pada this shape of tetrahedral sekarang, kita bukan setakat ada satu lone pair. Kita ada dua lone pair. So, dua lone pair bermakna, satu ikatan kena buang, ganti dengan lone pair. Satu lagi ikatan pun kena buang dan ganti dengan lone pair. And again, any two bond replaced by lone pair. Okay? Dan sekarang Miss nak buang. Mana-mana. Tadi saya buang mana-mana. Jujur, saya boleh ambil mana-mana je. It will still be the same. Tapi kena ganti balik dengan lone pair saya. Lone pair masuk. Lone pair masuk. Okay? So, what left? Syafiq, what left? What left? What is the molecular geometry now? V shape. My question, what would be this bond angle of the V shape?
104.5.
104.5. V shape atau band. And you can look at the bond angle right now change. Tadi kita ada V shape. Tapi V shape tadi adalah less than 120. V shape sekarang adalah less than 109.5. Kenapa less than 109.5? Sebab saya original adalah daripada tetrahedral. Okay? And looking at your lone pair, look at, we are going to draw it now. Okay? That is my V shape. I hope you can see the V shape. Look at your lone pair. Lone pair kamu dua-dua duduk kat atas. Betul? So, adakah lukisan Miss Wong betul sekarang? Tak. Kalau saya ada oksigen dan saya ada V shape yang pertama, hidrogen saya dua-dua ke bawah. Exactly like this. Alright, hidrogen saya dua-dua ke bawah. Lone pair, dua-dua duduk atas. See that? Okay. Kalau lone pair kita, kalau oksigen saya dengan hidrogen sengit ke sini. Sengit ke kiri. Parang sengit ke kiri. Betul? Look at where is your lone pair. Your lone pair is here. Nampak? Alright, nampak your lone pair? Guys, position of lone pair is extremely crucial. Okay? Alright. And yang Syafiq bagi tahu tadi, bond angle. Syafiq bagi satu value approximately 104.5. Betul Syafiq? Okay? Kenapa kena ada kenapa untuk yang ni kena ada approximately? Because this pakcik. This pakcik pun adalah less than 109.5. Okay? This pakcik pun less than 109.5, tapi dia adalah approximately 107.0 degree. Kenapa kena ada approximately? Sebab pakcik ni pegang satu lone pair je. Tapi pakcik ni pegang dua lone pair. So when I say it's less than 109.5, we need to show the presence of two lone pair will definitely have a stronger repulsion. Dia akan tolak lagi kuat. Dan bila dia tolak lagi kuat, V-shape kita akan jadi lagi kecil berbanding tadi. So, bila kita kata less than 109.5, dia kena lagi kurang daripada tadi. Certain buku akan ajar less than 107 pun kita terima. Okay? Yang pasti sayang, kamu kena tunjuk bahawa V-shape kamu kat sini lebih kecil daripada Trigonal Pyramidal. Make sense? Okay? And still, back to the drawing. Make sure you can draw. Make sure you know where is your lone pair located. Okay? Next. Kita nak pergi kepada antara yang penting. So you have your lone pair plus sigma plus lone pair. I'll just very quickly go through. 5 plus kosong, kamu dapat 5. Your basic shape adalah Trigonal Bipyramidal. Let me show you how a trigonal bipyramidal looks like. First and foremost, trigonal. So I want to show you the trigonal first. Okay? And this trigonal is a trigonal planar. This trigonal is a trigonal planar. Tak habis lagi. Sebab hasil tambah 5. Okay? Dia akan ada extra 2 more bond. Yang akan duduk, kalau planar ni, like this, dia akan duduk atas. Dia akan duduk bawah 180 degree antara dua ni. This is how your trigonal bipyramidal look like. Alright? You can see your trigonal, dia ada atas bawah. Can you see that? Okay. And tadi atas bawah ni masuk sebagai 180. Tapi tengah-tengah dia ada ikatan. That's why the bond akan jadi 90 degree. Betul? And then over here, you are having a triangle. You're having a trigonal. Tadi saya dah tunjuk dia adalah planar. So bermakna that is your 120 bond angle. Alright? A very different from others because in a trigonal bipyramidal, the shape that I will always draw looks something like this. And in here, you have 2 bond angle. You have a 90. You have a 120. Okay? Kalau siapa yang tak nampak, saya lukis laju sangat. Guys, we started off with a trigonal. And then we built a pyramid. Okay? Nampak? That is your trigonal bipyramidal. And yang ni sama sayang. So, shape dia sama. Yang ni tak payah nak cakap apa dah lah. Okay, trigonal bipyramidal. Sebab lone pair tak ada, so dia akan jadi sama. Bond angle is 90 and 120. Both kena tulis. And look at the way I draw. It's already in trigonal bipyramidal. Kenapa yang ni saya lukis siap-siap? Sebab banyak yang saya nak tunjuk. Selain daripada lukis macam tu, you can have your trigonal bipyramidal look something like this. Trigonal duduk sini. Betul? Okay. You boleh ada your trigonal duduk terbalik. Berbanding dengan yang ni, saya boleh ada trigonal saya segitiga macam ni. And then pyramid. Sama kan? Nampak dah? Membuka minda sikit. Alright, you can have your phosphorus in the center, still in the center. You can have your trigonal planar having a triangle like this. Atas bawah. Masih adalah trigonal bipyramidal. Can you see that? Okay. And this one, for the next thing, is important. Kenapa kat sini saya kata dia important is a 4 plus 1. You're still having a 5. Dan bila dia 5, you're still having a trigonal bipyramidal. Dan kenapa Miss Wong kata yang ni lain daripada yang lain? Because we have 2 bond angle. The original looks something like this. Having a 90 degree and having a 120 degree. Betul? Lain dengan trigonal planar, lain dengan tetrahedral, reason dia satu je. Sebab dia ada 2 bond angle. Dan sayang, looking at your structure right now. Kalau lone pair nak masuk, saya ada bond angle 90 degree. Lepas tu, kita ada bond angle 120 degree. And semua orang tahu lone pair, daya tolakan tinggi. Betul? Alright, next question. Yasmin, lone pair nak masuk pada 90 degree or 120 degree?
90 degree.
90 degree. Ain?
degree.
Oh dia. Lone pair akan ada repulsion yang tinggi. Repulsion adalah daya tolakan. Betul? So kalau daya tolakan dia tinggi, bermakna dia akan duduk kat tempat yang sejauh yang mungkin lah. Paling jauh saya boleh duduk, paling rendah lah repulsion. Saya tak nak tolak banyak. Betul? Okay? So kita akan masukkan orang yang kuat tu kat tempat yang luas. So saya ada 90 darjah dengan 120 darjah. 90 darjah dengan 120 darjah. Siapa lagi luas? Anyone? Naili? 120. Dengan kata lain, for your trigonal bipyramidal, okay, we are not going to touch the 90 degree. We are not going to touch these two. Alright, dua ni kita takkan sentuh. Yang ni dengan yang ni kita takkan sentuh. Okay, sebab dia 90 degree. So, lone pair yang kamu boleh ganti adalah mana-mana satu daripada segitiga ni. Okay, yang kamu boleh ganti mesti hanya adalah mana-mana satu daripada segitiga ni. Mana-mana je, tak kisah. And that is your lone pair. And guys, what is the name of this shape? Seesaw. Thank you. So the molecular shape will be seesaw when your trigonal bipyramidal having one lone pair. So what are you going to do is you are going to remove the bond, one of the bond in this segitiga, one of the bond in this segitiga because of the bond angle 120. Mana-mana satu ganti dengan lone pair, kita akan dapat our seesaw shape. And your seesaw looks something like this. Dan yang paling penting, kedudukan lone pair. So the bond angle again will be less than 90, less than 120. Cara nak lukis, you sulfur, straight, seesaw. Nampak? Dan yang paling penting guys, lone pair duduk mana? Nampak? Lone pair duduk mana? Okay. The same thing. Kalau Miss Wong nak lukis, my seesaw looks something like this. Okay. My seesaw looks something like this right now. It's still a seesaw, right? And your lone pair. Alright, your seesaw looks something like this right now. Saya lukis dalam bentuk ni. I hope you can see that your lone pair is over here on the left. Nampak? Position of lone pair is extremely important. Make sense? Okay, question? No? Alright. Next thing. Very quickly. So kat sini, that's why kita akan sentiasa hanya ganti segitiga ini sahaja. So T-shape kamu dapat sebab saya ganti mana-mana dua daripada segitiga ganti dengan lone pair. Sebab tu kamu dapat your T-shape. And your T-shape lone pair duduk atas dua-dua. Alright, you have a linear because we started off with a trigonal bipyramidal. Dan bila dia linear sebab dia ada 3 lone pair. 3 lone pair, ganti bonding dengan lone pair, ganti bonding dengan lone pair, ganti bonding dengan lone pair. That's why you have a linear with 3 lone pair like this. Nampak? Okay. And last but not least, over this one is all 90 degree. So when it's all 90 degree, okay, kat sini, for this one is you have one lone pair. So when you have one lone pair, ladies and gentlemen, you can replace anyone with the lone pair. The same story. Kenapa boleh ganti anyone? Because we only have one bond angle. So tak ada pilihan pun. Ganti je lah mana-mana yang aku suka. Dengan lone pair. Betul? Okay. But this one, a bit of tips. Dua ni. In here, lone pair. 2 lone pair must be 180 opposite to each other. Dia kena duduk paling jauh. So saya ada my octahedral over here. Bila Miss Wong ada 2 lone pair yang nak diganti, guys, 2 lone pair yang nak diganti tu mesti adalah bertentangan arah. Tak kisah yang mana kamu nak pilih. Tapi bila saya dah letak satu kat sini, kedua mesti adalah 180 degree bertentangan arah. Is that clear? Okay, yang ni je. Okay, question? If you have any question, you can ask. Alright. Afif, 13 structure saya dah kira. I want all the structure with the correct Lewis structure until bond angle and the correct drawing today. Thank you. Kalau Afif hantar lambat lebih daripada pukul 5 petang hari ni, satu kelas, bukan, satu kuliah kena buat. Thank you. My attendance ada soalan ya. Very simple question. One simple question. Answer that. And the answer is already in the class just now. Scan your attendance, off you go. And have a good day, Afif. Kalau nama kamu naik lagi tak hantar tutorial dalam kelas Puan Jalila, you'll be that man by next week. Is that clear? Come on, boy. You can do better than what are you doing. Ada soalan boleh tanya.